Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.3, Problem 9. This is Section 12.3, Problem number 9. It says find the derivative of f of x equals, in parentheses, 4x cubed over 5 minus 4 over 5x cubed, all in parentheses raised to the 7th power. So what I'd like to do is write this as a function that will fit the format for our chain rule and use the chain rule. And part of the problem is the variable being in the denominator in the second piece of the function, the 4 over 5x cubed. So before I do anything, let me just write f of x equals, now the first one, 4x cubed over 5 is okay the way it is, but really to fit the format that I'm comfortable with, let's make it 4/5 x cubed. That's the same. And then the second one, let's make it 4/5 x to the negative 3. Because of the x being in the denominator and having an exponent of 3, you can bring it up, and that could be written as 4x to the negative 3 over 5, just bringing the x to the third up into the numerator. But to fit the format to take the derivative of and x has an exponent and a number in front, I prefer to write it with a fraction in front. Now all that's going to be in parentheses. The 4/5 x to the positive 3 minus 4/5 x to the negative 3 is in parentheses, and it's raised to the 7th power. That's just the way the problem is. So I've rewritten the same problem. I haven't started taking any derivative yet. But now it really is a function that is f of x equals some stuff in parentheses to a power. So the derivative, f prime, the n, the exponent comes down in front of the stuff. Then you make a new exponent, which is n minus 1, times stuff prime, the derivative of the stuff. So that's what I'm going to fill in. So f prime of x equals, so my n comes down in front of the parentheses, and for this problem the n is 7. So I start with a 7, I open some parentheses, and I put the stuff the way it is, no prime yet. So the stuff is going to include 4/5 x cubed minus 4/5 x to the negative 3. Close the parentheses. Now my new exponent is 1 less. N minus 1 becomes 7 minus 1, so 6th power. Then times, and now stuff prime. So the first piece, 4/5 x cubed, the exponent of 3 is going to come down times the 4/5. So 3 times 4/5 can be thought of as 3 over 1 times 4/5. Top times top, 3 times 4 is 12. Bottom times bottom, 1 times 5 is 5. So the 3 exponent times the number in front, 4/5, gives a result of 12/5 x to 1 less power. So that third power is going to drop down to a second power. And now the same process for the second piece of the stuff, as I call it, negative 4/5 x to the minus 3. So again, the exponent of minus 3 comes down times the number in front of 4/5. The minus times the minus is going to cancel. And then you have the same numbers. 3 times 4/5 is the same as 3 over 1 times 4/5. And top times top, 3 times 4 is 12 again. Bottom times bottom, 1 times 5 is 5 again. So the exponent of negative 3 times the number in front of negative 4/5, once again, is 12/5, and because it's a negative times a negative, the result is positive. Then you have x to the 1 less power. Be careful now because it's negative. Negative 3 minus 1 goes down to negative 4. Close the parentheses. And that's the answer. If you like, you can put the negative exponents back into the denominators. You don't have to. I would probably leave it like this. So the final answer, f prime of x equals 7 times, in parentheses, 4/5 x to the third minus 4/5 x to the minus third, all raised to the 6th power, and then times another set of parentheses, which would have 12/5 x squared plus 12/5 x to the negative 4.